Welcome back, everyone. We're going to be solving LeetCode 700, search in a binary search tree. So we're given a root of a binary search tree and an integer value. We need to find the node in the binary search tree such that the node's value is equal to the given value. And then we need to return the subtree rooted with that node. And if no such node exists, we can just return null. So what about a base case? A base case would be if we're given an empty tree, then we obviously can't find whatever value that they're looking for, right? So we can say if root is none, we can just return none. Otherwise, in order to loop through a tree data structure, we generally are going to use a pointer, just like we would with linked lists. So we'll say current will be equal to the root. Current will be our pointer. Now, binary search trees have the following properties. Given a root node, in example 1, it would be 4. Given the root node, everything, all the node's values to the left of the root, meaning everything in the left subtree, has to have a value less than the root, and then the opposite would hold true for the right side, right? So the right subtree would have to be values all greater than the root value. And then every time we descend, so say we're at 2, in this case, this would be our root, then everything to the left would have to hold true as well. So everything to the left of 2 would be less than 2, everything to the right of 2 would be greater than 2. Okay, so now what we can do, we need to loop through our tree. So we will say while our current node is not none, what do we want to do? We want to check if the current position we are at, the current node we are at, has a value equal to our target value. So we'll say if the current value is equal to our target value, what do? They want us to return the tree, so we can just return the node we are at. In this case, it's current. Okay, so what happens if we hit a value that is less than what we're looking for? So that would be if current.value is less than the value we are looking for. That means the value that we're looking for is going to be in the right subtree, so we want to go right. So we will say current will equal current.right, and then if the current value is greater than the target value, that means the node's value is going to reside in the left subtree, so we want to go left. So we'll say current is going to be equal to current.left. And then if we ever break out of this loop, that means we never found a node that satisfies the given target value. So we can just return none. Return none. So we get rid of some of these spaces. We'll run this. Pass both test cases. We'll submit. None type has no attribute val. Cur is not none. If cur.val is less than val, greater than val, cur will be cur.left. What is going on here? Root, well, cur is not none. I should say elif. Okay, so we do pass the submission. Okay, so what about the time and space complexities for this problem? Space complexity, we're not using any extra data structures, right? We're just looping through our original given tree. So we are going to remain at constant space, O of 1. Time complexity, if you noticed, a binary search tree is pretty similar to the binary search algorithm, right? Where we're getting rid of half of our input tree every time we make a decision. So that is going to leave us with a time complexity of O of log n. And that'll do it for LeetCode 700.